Hello and welcome back. In this video we'll discuss rational exponents. Now rational exponents just really means using exponents that are fractions, and here's why we call them that. A rational number is any number that can be expressed in the ratio of a over b. I call it a ratio, but it's really like a fraction, where a and b are both integers. So this is the definition then of a rational number. So if I have something that looks like this into the, let's say, 1/2 power, this then is a rational number, 1/2, because it represents the ratio of two integers in a fraction form. And it uses an exponent, so we call it rational exponents. So when you hear the word rational exponents, you can simply think fractional exponents. Now, what does a fractional exponent mean? I'm going to start off with something real easy, and then I'll explain why. So let's do n to the 3/4 power. Here's what that really means. It means take the fourth root of n to the third power. And you'll see that the numerator right here is really the exponent, or the power of the base number, and the denominator of our fraction is really the root that we're taking. Now, a lot of people have trouble accepting why does that work. So we'll show why that works here in just a moment. Let's start with something like x to the 1/2 power. If we were to go ahead and take this x to the 1/2 power and square it, raise it to the second power, that means you're going to do x to the 1/2 times x to the 1/2, and that is really equal to x to the 1/2 plus 1/2, which of course equals x to the first power. So we know that this over here produces x to the 1/2 times x to the 1/2, which is really x to the 1/2 plus 1/2, and 1/2 plus 1/2 is really 1, and x to the first is really just x. All right, so let's go back to x to the 1/2 power. We said, how do we know that that means a square root or a root of some sort? Remember, we have something that was raised to the second power, and using the transitive property up here, we can say that x to the 1/2 power squared is actually equal to x. Remember, there's a power of 1 on that. And what we want to do then is find out what x to the 1/2 is. So get rid of that 2 on the outside. The way we get rid of the 2 is we take the square root. So if something's raised to the second power, we undo that by taking a square root. We do not divide by 2. But if I do the square root on the left-hand side of my equation, I got to do a square root on the right-hand side of my equation. This square root operator cancels out the power of 2, leaving x to the 1/2 power, and it's just going to equal the square root of x. All right, so how do we know that the 1 belongs here? Because we saw the 1 up there, but the 2 is on the outside. Well, anytime we take a square root, we normally are supposed to put a 2 there, but since the normal square root means the 2, we usually leave it off. So x to the 1/2 power really means the square root of x. And we'll show you how that works here. If I have 16 to the 1/2 power, that really means take the square root of 16 to the first power. Well, 16 to the first power is just 16, and the square root of 16 is going to be plus or minus 4. So 16 to the 1/2 power could equal 4, or it could equal -4. If we have 8 to the 2/3 power, then that means we are going to take the cube root, because the denominator is the root, cube root of 8 to the second power. Now, some people ask, well, what if you wrote it this way? The cube root of 8 and then raise it to the second power. Would you get the same answer? Yes, you will. This is one of the rare cases where it does not matter which one you do. And in fact, it's even easier to do it this way, because the cube root of 8 is just 2, and we still have a power 2 on the outside, and 2 times 2 will give us 4. So if you actually have a calculator that can do exponents using fractions, and you were to put 8 to the 2/3 power in it, you'll see that it evaluates out to 4.